I'm not saying there's going to be a giant outbreak of methane, but I'm saying that that is a possibility that's suggested by what's been observed by the people who actually go out there and do measurements.
It came to me that there's this huge disparity between people who think it's the end of the world, literally and figuratively, because there's a methane release that's begun in the East Siberian Arctic region, on that this is uncontrollable. It's started, it's ramping up. And then there's the huge majority of people, wherever they are on the scale of understanding and acknowledging climate change is real and happening, to activism, all of those people, there's a lot of them who say, oh, we can still pull out of this nosedive we're in. And the thing that separates you into the one camp, the hair-pulling camp, and the it's okay, the rather sanguine camp, is the Arctic methane. And is it coming out quickly? And what are the prospects? So I wanted to ask your experience about that and how you read other scientists. So this is a video released by Yale Climate Connections. The particular animation we're going to tune in on comes from the U.S. Geological Survey, and it starts off with Carolyn Ruppel.
Releases methane all of a sudden. That is not a scientifically sound worry.
I don't think we need to be afraid of any catastrophic methane release from the Arctic anytime soon, certainly not in our lifetime.
If we mitigate or reduce human emissions, looks like you can avoid 70 to 80% of the permafrost climate feedback. That means that the size of this ecosystem feedback to climate depends almost completely on what we do.
Okay, I think that's enough. Let me stop the share. It's there responding to one woman who was freaking out over it and just had to get to the bottom of it. And so Yale is putting out this 6.5-minute missive saying, don't worry about it. But I wanted to get your input on what is being stated here, what's being implied.
Well, it's staggering in a way. First of all, why did Yale feel the need to produce this, to haul together a bunch of scientists who are basically not basing their statement that nothing's going to happen on scientific principles or on observations, but simply to say these things don't happen, and as a scientist I say they're not going to happen. It's a very surprising kind of unscientific denial by all of those people. And the fact that that Yale felt the need to put something out that denied that something was going to happen is also extraordinary. That you don't do that really unless you're actually worried that it might happen and you want to instill complacency, because you don't say some extremely unlikely event like the Earth being hit by an asteroid. It's accepted that it might happen, very unlikely, of course, but could happen. So the odds or the likelihood of it happening are known, and we of course don't have much of an idea what we would do if it did happen. But it's not something that a university would feel the need to deny, to put out a statement with some distinguished astronomers denying that it would happen. That's strange.
I didn't start the video early enough, perhaps, because the only evidence they give is from Carolyn Ruppel. Let me see if I can go back a few seconds in that video and cue it.
And in fact, the thermodynamics helps you a lot on this because of the nature of the reaction. It's an endothermic heat reaction. This is a problem when we try to produce methane from hydrates. It keeps shutting itself down. right? So it's not a situation where we trigger breakdown and that breakdown is going to suddenly, like the whole deposit's going to release its methane all of a sudden. That is not a scientifically sound worry.
So she says because the methane hydrates are endothermic, they need heat, they absorb heat. Well, that's what we're talking about. The Arctic is heating up.
Yes, I mean, I don't understand what she's getting at. Yes, it's an endothermic reaction, and so methane hydrate, to turn itself into methane gas, absorbs heat. But I think the point about the danger here is that there is heat available, and there will be a lot more heat available as the protective permafrost layer on the seabed thaws. So it's the first thing is there's a kind of, it's like a pressure cooker. There's a layer of frozen ground. Basically, it's like permafrost on land, except it's at the bottom of the sea from when that area got flooded, and it's there protecting the methane hydrates from actually coming out. And it always has since the last ice age, but the situation's changed completely. Instead of the seabed being at or near the freezing point because there's sea ice over the top of it, and that keeps the coastal waters, the shelf waters at or near the freezing point year round. Instead, we've now got an increasingly long period in the summer, it's up to about 4 months now, where the shelf waters are exposed to the atmosphere. There's no sea ice there, and they warm up. And I've measured 11 degrees in the Chukchi Sea, north of Bering Strait, which is the temperature of an English seaside resort in summer. And the amount of warming up of the coastal waters is quite amazing. It's getting more and more each year. And once that heat burns its way through or gets through the protective layer of permafrost, then the methane hydrates, although they need heat to turn them into methane, they're going to have that heat because that heat is then coming in from the warm shelf waters, which are now in touch with the methane hydrates because the permafrost layer has thawed. So it's a different situation than we've had before. It's only been a situation for the last decade or so since serious retreat of the sea ice from coastal regions of the Arctic happened. So it's a different world, and so she should be looking at the data that's been obtained in that different world, and that's really by these Russian groups like Shakova, instead of ignoring the data and thinking and saying that something else is going on. It's not a sort of stable, slowly varying thermodynamic situation now. It's a new dynamics, and that's what's important about, and I mean, I'm not saying there's going to be a giant outbreak of methane that will cause a huge increase in global temperatures, but I'm saying that is a possibility that's suggested by what's been observed by the people who actually go out there and do measurements. An increasingly small number of Arctic people actually do measurements in the Arctic.
An increasingly small number. A decline.
Yes, an increasingly small number of field scientists operate in the Arctic now. So, but you should pay attention to what they say because they're the ones who do the measurements.
But Natalia Shakova is not notoriously vocal publicly. She doesn't give very many interviews. So it's very hard to know what their research has indicated recently. Have you had recent touch with her? Do you know what the assessment is now of the heating and the methane outbreak?
Well, not very recent. No, I mean, I basically go on her published papers, and they have a large number of papers published in good journals in Nature and Science on what their observations demonstrate. And not only, they're not demonstrating the potential outflow of methane from the Arctic. They're demonstrating the real production of methane from the seabed. There's data from underwater vehicles showing methane plumes, and these are things that really would worry me. I mean, I've seen gas plumes coming up from in the Arctic because of having worked on oil blowouts, and this is the same thing. This is a seabed source distributed over an area of maybe a kilometre or two, producing a large amount of bubble plumes where the methane is the bubbles and coming up to the surface and being released into the atmosphere. And they're there. So whenever you go to the Arctic, to the East Siberian Sea, and now also to the Laptev Sea and the Kara Sea, and you see these things, and it's not just, if you don't want to believe the Russians for some reason, it's also been done by the Swedes and Norwegians and other people involving expeditions on the Odin, which is a Swedish icebreaker. They see exactly the same thing. So everybody who goes there sees this thing happening, and then the scientific question is, will this process accelerate to the point where it's giving out enough methane to cause a global climate impact, or is it something that will remain at a fairly low level, something that you see when you're up there, but won't necessarily accelerate out of hand? That's the question, but you have to base your thinking about that on the sum total of the observations, and they're not just Shakova, although she's done a huge amount of work, but it's also the people on the work from the Odin, and that's the whole Swedish and Norwegian group. So it's very odd. I've noticed this kind of denial of methane seems to be the. Well, no, why? I mean, it's not as if we're talking about kind of extraterrestrials or telepathy or one of the other, some other field of science that's forbidden to discuss or do anything with.
Physics.
It's just methane. It's stuff.
Ah,
it's stuff coming out the sea.
Yeah. Now, one of the things that I wanted to share again by video now, we'll watch a little tiny bit of an interview with Natalia Shakova. I want to start getting underneath this idea of why the worldview of scientists might affect their objectivity. So if I may, she's discussing her attempt to get a paper published in Nature Geoscience. Here, let me see if I'm at the right point.
Our American colleagues, they reported about a few hundred plumes in the North Atlantic area. They didn't measure even methane in the water column. They didn't do anything. They just recorded the plumes like that. But they reported fluxes already, extrapolated to the area.
Okay.
And they never been beaten for that?
And they've never been beaten for that? In other words, that's not sound. Okay, let's go on.
They've been published, and they're well done. We're doing 10 years.
Now she's talking about her work in the area.
We developed the method of direct measurements, in situ calibration, unprecedented. No one did that before. And we do have the idea how we could extrapolate. We did come up with the ranges of the fluxes, but we still cannot do extrapolation because everyone says, what are you doing? How could you?
So they doubt her extrapolation based upon actual fieldwork because it's so high in comparison to the rather sanguine, NASA, NOAA, American, USGS. She says a couple of other things that she put her paper out there, and the only comments that she got back were similar, like, you can't publish this data, it must be wrong. Your data must be wrong. Excuse me, I went there, I measured. So she is implying in that interview that scientists are defending turf. So I wanted to get your view and maybe personal experience on a censorship within the scientific community, if you could take that question away.
Yes, well, it's partly censorship and partly simple, I guess, lack of objectivity, which scientists don't apply to other things, but they seem to apply to methane. When the first measurements of methane under emissions from the seabed were done by a British scientist, whom I won't name, but he saw methane coming from the surface off Spitsbergen at a water depth of about 500 meters. And in that distance, methane dissolves as it rises, it gradually dissolves. And so the methane plumes that he was seeing started at the seabed and didn't reach the surface. They disappeared on the way up. And that was a very nice paper because it showed these methane plumes coming from the seabed disappearing because the methane was dissolving. But Natalia's work, when and Igor, when they started working, they were working in the East Siberian Sea, where the water depth is only about 60 meters. So in 60 meters, the methane comes out. The plumes that they observed and actually recorded on sonar and filmed with underwater vehicles were there, coming up to the surface, the methane coming out. So it's a different world from the deep water case. And yet the person who did the deep water work poo-pooed everything that Shakova had done, because he said you can't get, methane dissolves on the way to the surface, so you can't get any methane emissions, but ignoring the fact that the water depths were completely different. So there was something where you'd think an elementary scientific principle would be understood, but it wasn't. So you can't quote measurements that you make in the deep water of the Atlantic or even in the Bering Sea, which is similar to the seas north of Alaska, and say there can't be methane emissions from the East Siberian Sea because we're not getting any in the Bering Sea or in the North Atlantic Ocean. It's unscientific thing to say. So it sounds as if they're trying to demolish her paper on the grounds that it can't happen because it hasn't happened somewhere else that we've been. But that's completely unscientific, and I'm just still puzzled as to why methane should be a topic where kind of rationality no longer seems to act.
If I can, I'm reminded of another non-scientific metaphor in a tale. Nasruddin is a famous fictional person in the Sufi, the metaphysical arm of Islam. So Mullah Nasruddin is sometimes represented as a wise person and sometimes as a fool. He's the wise fool. And so in this particular parable, friends come walking along the street and come upon Nasruddin looking on the ground outside of his house, and they say, this is at nighttime, and they say to him, "What are you looking for, Mullah?" And he says, "I'm looking for the keys to my house before I go away for the evening. I have to lock my house. I can't find the keys." And they say, "Oh, well, let us help you." And they're looking for a while, and they said to him, "Well, where did you lose them?" And he said, "In the house." And they look at him shocked, and they say, "Well, why aren't you looking in the house?" And he says, "Because there's no light in there." So why are these scientists looking out under the streetlight for the methane release when there's none under the streetlight? Anyhow, I think we're going to have to go to just descriptive terms of probable or improbable or very probable. Where do you see the probability of a significant enough methane release within, say, the next 5 to 10 years?
I wouldn't venture to say what the probability is of a catastrophic methane outbreak, but I wouldn't put it as infinitesimally small. I'd say it might be something like 20 or 30%. It's significant, and it needs to be studied because when we do analysis of climate change risks, we should be doing risk analysis. And in fact, there's an increasing movement really to say, when you assess what's happening, what are the nasty things that are going to be happening to the planet or may be happening, we should be doing a risk analysis, which means you look at a phenomenon that may or may not happen, like a big methane release. You estimate what the probability is that it will happen based on all the data that you've got and modelling. And then you calculate what the cost would be if it did happen, multiply the two together, and that's your risk. I think it is the case that the world's coming round to doing risk analysis on many aspects of climate change, as opposed to the Intergovernmental Panel on Climate Change approach, which is not quantitative in that way. But this is with the single exception of methane risk, because that would seem to be a very clear risk and something that, in fact, was picked up on by one of the leaders in Britain of the climate change research, saying, well, here we have an effect which, if it happened, would be very serious. We can more or less assess the probability it will happen. So we can do a risk analysis on that. And that may be one of the biggest risks in climate that hasn't been considered so far. That was then just squashed. It hasn't been done and hasn't been funded. And for some reason, well, I think I can think of the reason. I think the reason is that if it did happen, it would be very, very serious. I mean, it would be a step change in global temperatures of, well, we've done an estimate, it might be 0.6 of a degree, and that's only with a fraction of the methane in the sediments of the Siberian Sea coming out. But if you had 0.6 of a degree or more, it may be, then in one step, I think people need to think what that would do. I mean, we're concerned about warming, global warming, and we bandy about figures like saying 2 degrees is the maximum we can allow by 2050, or preferably 1.5. What we might really get is 4 degrees by 2100. These are all assumed to be temperature changes which occur gradually, well, not that gradually, increasingly fast, but not catastrophically. But if this 2 degrees, for instance, happened in 1 year, suddenly because of a vast release of methane, what would it do? We could understand 2 degrees over 30 years and the world could gradually adapt or not adapt, but at least the change would be slow enough that we could change our habits, what we could do, what we can try and do about it. But if it all happened suddenly in 1 year, we would just be completely flummoxed. We wouldn't have a clue what to do, and the effects would be as great as 2 degrees in 30 years, but they will be happening instantly. Nobody, as far as I know, has modelled what the impact of a large step change temperature in climate would be.
If it can't happen, you know?
Yeah, if it can't happen, you don't have to model it. Even if it's not huge, but the finite probability that there will be a catastrophic methane release means that we have to do the research on what would be the consequences of such a rapid release. But we're not doing it. Nobody's doing it because everybody's so afraid of giving any sort of credence to the possibility of a big methane release that they don't want to even look at what the consequences would be. And that's really very, very scientifically bad. Remember, there was a book some years ago about what will be the consequences of a nuclear war. The new concept of a nuclear winter came out of that it could produce a complete loss of habitability of the planet because of nuclear winter.
A great many reputable scientists are telling us that such a war could just end up in no victory for anyone because we would wipe out the Earth as we know it.
But somebody went to the bother of working out what would happen if we had a nuclear war. And it's not just that everybody's going to be killed by the explosions and the radiation and so on, but there's this climatic effect as well. Mm-hmm. So they did that work, and that's hopefully made the politicians of this world even less likely to fire off nuclear missiles. But nobody's doing that analysis for a methane catastrophe or large methane emission, and they should. It might not be that bad, but it might be very serious indeed.
I keep wondering who the they is that decides. You may have mentioned it already, and I missed noting it.
Well, who are they? The first line of defense against knowledge are scientists themselves and science funding agencies. So, for instance, Natalia is complaining that she couldn't get a paper published. Now, it's probably a perfectly good paper, but it goes to referees, and if all the referees are endowed with this, let's not think about methane, it won't get published. And the funding agencies, and she's had this problem with funding agencies as well, that will support work, the actual measurements that have to be made, which costs money to go out in ships and do this, they're not willing to support field research. And I've had that problem with proposals I've written with others, in fact large groups of scientists, to funding agencies, that they simply find reasons why they can't support it. And it's really difficult to get support to do that sort of work. You would hope that it would be regarded as a high priority, but it's regarded as something where the agency can find reasons to turn it down. So the science doesn't get, the measurements which are vital don't get done because you can't get the funding to go out there. If you've done the measurements and you've got the results, you can't get them published because of the referees, the biases of the referees. So that's quite powerful defences against human knowledge, which are set by science and science administrators. So you break through that first, then you have the problem of what do we do as a world or as a society confronted with the risk like that maybe needs some precautions being taken.
Human folly, even in the scientific community.